Hello, today we'll start our section on analogical arguments. For this lecture, we'll talk about the framework of analogical arguments. To begin, we can ask what an analogy is. To draw an analogy is just to indicate similarities between two or more things. So when Forrest Gump says life is like a box of chocolates, you never know what you're going to get. He's comparing life to a box of chocolates and saying they're similar in this respect. So with a chocolate, you might get a nutty one, you might get one full of nougat. With a box of with life, you might get a great job, you might have a kid, you might go on a trip. You never know what you're going to get. At any rate, to draw an analogy is to just indicate similarities between two or more things. Now, an analogical argument, this is an argument which finds characteristics that two or more things have in common and concludes that the things being compared probably have some other characteristic in common. So, you have two objects, two events, two things, whatever it is. You're comparing them, and you're saying, hey, look, they have all these characteristics in common. And you're concluding that those two things probably have some further characteristic in common. Let's look at some examples. First, though, we'll look at the form of analogical arguments. Here we are. Objects x and y have characteristics a, b, c in common. X has characteristic k, therefore y has characteristic k. So you're saying that because x and y are similar in all these different respects and that x has this further characteristic, it's a further characteristic that we know about x but we don't know about y. Well, given that x has it, we can conclude that y has it. Look at the example below. Phil 101 and Phil 102 are both philosophy classes taught by the same professor, have similar papers and tests, and are highly abstract. Phil 102 was a difficult class, therefore Phil 101 will be a difficult class. So you're noting that Phil 101 and Phil 102, at least the particular sections that you're looking at, they're both philosophy classes taught by the same professor, the papers and tests are similar, and they're both highly abstract. Those are all the things that they have in common. We know they're in common. But we notice that Phil 102 has this further characteristic. It was a difficult class. So say you already took it and you had trouble with the class, and you got a grade you didn't expect because you wanted a higher grade and you didn't think it would be so difficult. Well, given the similarities between Phil 101 and Phil 102, you judge that Phil 101 will be a difficult class. That's an analogical argument. You're comparing two things. You're recognizing that they have certain characteristics in common, recognizing that one of the things has a further characteristic, and concluding that the other thing will have that same characteristic. Okay, here's another way of looking at the structure. You have x and y. Here we go, x and y. Those are the objects that are being compared. And you have a, b, and c. Both objects have these characteristics. They're the characteristics in common, or the known similarities. And k is the inferred characteristic or similarity. So you compare these objects. You notice they have all these things in common, and that they probably have this further characteristic in common as well. Okay. Remember that example about Phil 101 and Phil 102? Here's a graphical way of looking at the argument. So you see you have two overlapping circles. These are called Venn diagrams. The circles are the two things being compared. Phil 101. So this circle is Phil 101 and Phil 102. This circle is Phil 102. The lowercase letters on the inside are the characteristics or properties that are in common. So you notice that A, B, C, D, and E fall within this area of overlap between Phil 101 and Phil 102. A is not something that's had by Phil 101 but not Phil 102. A is not something that's had by Phil 102 but not Phil 101. All the characteristics A through E are shared by both Phil 101 and Phil 102. And then you infer that F is within this area. It's something that's shared by Phil 101 and Phil 102. So remember, the circles equal the two things being compared, the lowercase letters equals the characteristic or properties in common, and the lowercase letter f is the new characteristic that the argument concludes the two things have in common. What do you think? Are analogical arguments deductive or inductive? You can pause it if you need to, but I'll say the answer. They're inductive. How so? Take these two situations here, this one and this one. Both situations are possible given the premises of the sample argument that we looked at. So the argument is inductive. So on this side, A, B, C, D, and E were supposed to be in common, or they were known to be in common, and then we inferred F. It's possible that F is in common for both Phil 101 and Phil 102. But on this side, this is also possible. Even if A, B, C, D, and E are in common, maybe Phil 102 is the only class of the two that is difficult. So just because two things have a bunch of similarities, it doesn't mean that they're going to have some other similarity, right? So it's inductive. Now, some analogical arguments can be strong, while others can be weak, right? And it's not something you can really quantify. It's something that you really have to weigh to determine whether they're strong or weak. You know, does this make the conclusion more likely than not? Or does it make the conclusion just as likely or not, or lower? Those are the things you have to ask and kind of weigh the merits of the argument in order to determine whether the argument is strong or weak. So, but the point is, since it's possible for F to be had in common by Phil 101 and Phil 102, and it's possible for F to be had only by Phil 102, the truth of the premises does not guarantee the truth of the conclusion, so it's an inductive argument. That's the structure of analogical arguments. Next, we'll get to the analysis of analogical arguments.